Welcome to this explainer. Let's just dive right into it. We've all looked up at the night sky, right? We've all recognized that familiar, friendly face looking back at us. But today, we're going to investigate why the familiar man in the moon is actually one of planetary science's absolute greatest and most fascinating unsolved mysteries. Literally almost every human culture has looked up and seen those dark spots forming shapes or faces. But very few people realize that those spots aren't just, random discolorations. They actually represent a massive structural anomaly. In fact, by the end of this explainer, we're going to answer not just why we see a man in the moon, but something even more fundamental: why we can even see our bright moon in the first place.
Okay, so to understand the face, we kind of have to define its features first. Those dark shapes, they're officially called Mareia, which is Latin for seas, mostly because earlier astronomers literally thought they were oceans. But modern science shows they're actually ancient lava flows. And here's where it gets really weird. They are sitting almost exclusively on the near side, the side of the moon permanently facing Earth.
So, it turns out the moon is basically lopsided. Actually, 4 separate NASA missions, including the Grail mission, confirmed these 3 really striking differences. First, the near side crust is half as thick as the far side. Second, those dark Mareia cover about a third of the near side but less than 2% of the far side. And finally, the far side sits at a significantly higher average elevation. It's almost like 2 completely different moons just got welded together.
So how exactly does mainstream science explain this? Well, according to the standard uniformitarian model, this lopsidedness is basically a mix of internal heat, tidal heating, and maybe an ancient random impact on the far side by some companion moon. But our source material notes that this is still highly contested. There's really no consensus mechanism fully accepted by the planetary science community just yet.
Enter the Unified Theory of Geologic History, or UTGH for short. This framework proposes a radically different mechanism. Rather than internal lunar processes, it points to a massive, directed bombardment originating right here on Earth. Yeah, no kidding. It suggests the near side was painted by debris from an explosive, catastrophic geologic rupture on our own planet.
Section 1. A primed and ready crust. To wrap our heads around this radical idea, we first have to look at the unique precondition of the lunar crust before this proposed event ever even happened. The UTGH framework suggests the moon's near side was basically like a cocked gun, just primed and waiting for a trigger. Over billions of years, Earth's massive gravitational pull constantly flexed the near side of the tidally locked moon. This is called tidal flexure, and believe me, it generated an incredible amount of frictional heat.
Now, just notice the sheer contrast between the two hemispheres here. This constant tidal locking really thinned out the near-side crust, bringing the underlying magma roughly 18 kilometers closer to the surface. It created this highly fractured network of rock. Meanwhile, the far side, which was shielded from Earth's direct gravitational flexing, remained a thick, untouched 80-kilometer deep-sealed vault. So the spring was totally wound.
Section 2. The Dark Ancient Moon.
But before any trigger was pulled, before any lava ever flowed, the framework states the moon looked completely different than the glowing orb we're used to seeing today. And this goes straight to our focus on why we can even see the moon at all. Before the event, the moon was raw, dark basaltic rock with an albedo, or reflectivity, of just 0.07. That means it absolutely absorbed light rather than reflecting it. It wasn't until later that it transformed into the bright, highly reflective 0.12 albedo object that we navigate by today.
Now, I know it sounds like science fiction, but the ancient Greeks actually recorded traditions of the proselines. It's a word literally meaning people whose ancestors lived before the visible silver moon existed in the sky. Wild, right? They weren't describing a young Earth with no moon. They were describing, with a real sense of awe, a sky where the moon had simply not yet been brightened.
So, against a thicker, luminous pre-flight atmosphere that scattered light uniformly, the framework proposes the moon was essentially a dark void. It was like an absence moving through the stars. Really, a presence that you sensed rather than actually saw.
Section 3. Triggering the lunar Mareia.
Okay, so what actually pulled the trigger on that cocked gun? Well, the UTGH proposes a very specific chain reaction. It started with a totally catastrophic subcrustal rupture right here on Earth. Supercritical water and rock blasted upward into space as hypersonic ejecta, basically hammering the perfectly primed lunar near side. That intense bombardment fractured the thin crust, which triggered the shallow magma to erupt and pool into the dark lava flows that we call
the Maria.
The absolute crucial point here is the speed. This ejecta was traveling at an incredible 47 to 93 kilometers per second. Because this material traveled so intensely fast, we're talking 20 to 40 times lunar escape velocity, lunar gravity just couldn't pull the debris around to the far side. It hit the near side straight on. And that explains perfectly why the far side sits in a geometric shadow, retaining its thick crust and boasting almost zero Maria.
Section 4. Lighting up the sky. But this explosive bombardment didn't just cause massive lava flows, it fundamentally changed the appearance of our night sky forever. The arriving terrestrial ejecta deposited a thick, stratified layer of really fine silicate powder all across the surface. This is what we call the lunar regolith. And according to this framework, the heavy concentration of regolith on the near side isn't just the product of billions of years of random micrometeorites. No, it's the direct result of a single, massive deposition event from Earth.
Just think about the sheer kinetic force of all that material hitting the moon at once. The momentum transfer was so massive that it acted as a discrete impulse. It literally pushed the moon's orbit outward by about 1,500 kilometers. And this directly explains why we see the moon at all. This highly reflective silicate powder essentially doubled the moon's reflectivity, like almost instantly. The dark basalt was frosted in this brilliant white powder, lighting up the night sky and creating the bright silver disk with its dark Maria face that all human civilizations have navigated by ever since. It was a total game changer.
Section 5. Evidence from the far side.
Now, while this is a pretty radical framework, it actually generates testable predictions. For decades, we only ever had near-side samples. But when China's Chang'e 6 mission brought back the first ever far-side samples in June 2024, the framework points out that the results perfectly matched its predictions. The far side showed less than a third of the water content, a total absence of Earth-like creep mantle elements, and far fewer impact melts. It really looks like the terrestrial debris truly only hit the side facing Earth.
And the UTGH continues to put its chips on the table with specific, falsifiable predictions. It states that, as high-resolution gravity and geologic maps are cross-referenced, we are going to see the near-side Maria boundaries correlating perfectly with the 53-kilometer crustal thickness contour. That's the exact threshold where the pre-event crust was thin enough to allow magma to erupt through.
This framework completely upends how we look at the night sky. It changes the moon from a silent, separate rock into an active witness of Earth's most dramatic history. It leaves us to wonder if the man in the moon is actually the scar of Earth's ancient rupture, and its very brightness is just dust from our own planet. What other incredible secrets are hiding in plain sight out there in the solar system? Thank you so much for joining me for this explainer. Keep looking up and keep asking questions.